We're going to analyze the behavior of this sequential circuit containing a D flip-flop and a JK flip-flop. And this analysis is based on the evolution of signals given in the right-hand side. At the bottom we see the clock, and here we see different signals that are part of our circuit. The main observation here is that both flip-flops make a transition when there is a raising edge of the clock. So the trick to analyze this type of circuits is to focus mainly on the value of the signals right at the instance before the raising edge of the clock. And this is precisely what we're going to do. So at this instance before the edge of the clock, we know that x has the value 1. If x has the value 1, it is enough for us to deduce that d has also the value 1. We also know that a and b, as given here, have initially value 0. A value 0 on the output of this latch implies that the opposite value is coming out of this output, and therefore we have a value 1 in both the J and K signals of this flip-flop. After making this analysis, we can translate this data to the diagram. So we say that D becomes 1 right before the edge. We know that J and K have the value 1, and therefore we can draw them like this, J and K. And now what we have to do is apply the transition rules for both flip-flops. So in the case of the D flip-flop, a 1 in the input means that this 1 will become the output immediately after the edge of the clock. In the case of the JK, a 1 value in the inputs means that in the next stage the value of the flip-flop will go to the opposite value that had before. Therefore, what we know now is that A will become 1, so we can deduce this transition immediately after the edge, and this 0 will become 1 because the 1-1 combination here inverts the value of the output. So this is the value of A and B after the clock. And we can reflect that also in the diagram. Now from here, what we do is re-evaluate again the entire circuit. But now we have to go to the second edge of the clock right here, and we go precisely to the value before the edge. In that value before the edge, the value of x switches from 1 to 0, and now we can recalculate the additional signals. Like for example, if we have an 1 coming out of this output, the opposite value, that is a 0, will come out of this output, and therefore it enters the JK flip-flop. Both entries are set to 0. And as we can see, this value 1 over here, when going through this gate, produces also a value 1 in the input of the D flip-flop. So we can reflect this change in here, saying that D remains 1, J and K go to 0, and A remains to 1 all the way through here, as well as B. And now we apply the same rules again. Now with this in mind, whenever the edge of the clock comes again, we know that this flip-flop will maintain this value because it has a 1 in the input which will be translated to the output. And, very important, this flip-flop JK has the value 0 in both of its inputs, and therefore what it's going to do, it's going to remain with the value 1 at the output. Therefore, in the instant immediately after the clock edge, this is the status of these three signals, A, B, and X. And as we can see, X will remain 0, this is an input. A and B will remain 1. And the only thing missing is to recalculate the values, but as we can check, they both remain exactly the same. That is, D remains 1, and J and K remain the value 0. And this is the end of the analysis.